All right, guys, it's 7:05, so let's get started. This is our third lecture, the Intro to Bot Making lecture. And today we're going to be showing you how to make a basic bot, going through all the methods you're going to need to know. And yeah, it's going to be great. I'm Hank, and this is Livia, and let's jump right into it. And today we're going to be showing you how to make. I'm hearing myself echoing, and I don't like it. Okay, so maybe you guys have already started working on some bots. We're pretty much going to go through like a basic bot here from scratch. If you looked at the example funcs player already, it's a little bit similar to that, although we have some optimizations here that should make this bot a bit smarter and more interesting to watch. So first thing is when you make your bot, it's very important before you try to do anything else that it is spawned into the game, because if it's not spawned, none of the methods will really work. If you try to do get location, it will return null. So first thing, before you try to do any actions in your bot, it's important to check that it's spawned. So to do that, we're going to make this try spawn method here. And let's go ahead and implement that. So first thing is we want to get a list of all the possible locations where we could spawn a bot, like a list of all the locations that are in the 3 spawn zones where you're allowed to make your bot. So let's do that. We can say map location array locations equals rc.get ally spawn locations. And this will get us all the locations where we're able to spawn. And then we can just loop through all of these and check if the bot is able to spawn at any of these locations. It might not be able to spawn at any particular location, like if there's already another bot spawned there. So we have to check if it's able to spawn at each location. So for each one, we'll say if rc.can spawn at that location, then we will spawn our bot with rc.spawn at that location, and then break out of the for loop since we've now added our bot to the game. Okay, so pretty simple, just spawning your bot. Okay, so after we've done that, we want to check to make sure that the bot actually did spawn successfully before we try to do anything else. So here we check with rc.isSpawned. And if that is the case, then we can go ahead and do the rest of the logic for our bot. So like our high level idea here is we're going to have a strategy for the setup phase, and then we're going to have like a separate strategy for the main phase of the game. Because as you may know, like the first 200 rounds, the goal is to set your flag locations and build defenses and things like that. So the first 200 rounds will be basically just like exploring. And then after that, we'll be trying to capture the enemy's flags. So in order to do that, we've split up the structure of our bot into multiple files. So we have this setup file here that I've already made, and also another file for the main phase. So this is the entry point to our bot, where it first starts running is in robot controller. So here we want to check if we're in the setup phase or if we're in the main phase, and then depending on that, we can decide which of the other files we're going to call to run our logic. So to do that, the easiest way is to get the round number, or they're actually, yeah, let's get the round number. So to do that, we can say int round equals rc dot get round number. And then if round is less than or equal to game constants. Game constants is a file that has lots of useful constants for you to look at, like vision radius and attack damage and the setup phase length and lots of things like that. So we'll check if we're in the setup phase by checking if the round is less than setup rounds. And then we'll do setup dot run setup, which is the method that I already made to run the setup phase. Otherwise, we'll do main phase dot run main phase, and then we'll get to implementing both of those in a second. So let's start with the setup phase. So this is the code I have so far for what our bot's going to do during the setup. Again, it's going to be pretty simple. Like the main goal here is to give you guys an idea of all the methods that you can use and like a high level strategy, not like super advanced micro optimizations, which will come in later lectures. So we're just going to go through like all the like very basic things that you might want your bot to do. So my idea for the simple strategy here was that for the first 150 rounds of the setup phase, I'm going to just pick up a flag from the spawn location if we can, and then wander around and try to find a place to put down the flag. It's not going to be very strategic. Like in an actual game, you might want to find like a good defensive location for your flag. We're just going to kind of wander randomly and then drop the flag after 150 rounds. But hopefully this will give you an idea of how it should work. So first thing is, if we're in this first 150 rounds where we're just going to explore, we're first going to see if we can pick up a flag from the spawn location. And if so, we will do that. So to do that, we'll first get a list of all the flags that are near the robot with the sense nearby flags method. So to do that, we can say flag info array. This method will return flag info objects, which tell you like where the flag is, if it's picked up, which team it is, things like that. So we'll say flag info array, flags, and then we will sense nearby flags. This method takes in two parameters. One is the distance to sense flags from. If we put in -1, then it will sense up to the maximum distance that the robot is allowed to sense. So I usually just use -1. And then we can also specify a team to search flags for. So we're going to say rc.getTeam. Since right now we're only looking to pick up our own flags from the spawn zones and go take them somewhere. So we did that. Now we're just going to loop through these flags and see if we're able to pick up any of them. So to do that, I'm just going to make a for loop here for flag info flag and flags. If we have this can pick up flag method. So instead of a flag info object, this takes in a flag location. So to do that, we'll just say flag.getLocation. So if we can pick up that flag, then we will pick up that flag. And once we found it, then we can just break out of this loop. So this is basically just the code for finding a nearby flag and picking it up. And then once you've picked up the flag in these first 150 rounds, our strategy is just going to be explore randomly around the map. And in order to do that, I've made another file that's going to hold all of our pathfinding code. So again, in this lecture, it's going to be pretty simple. We're just going to, for now, make a helper function that sort of explores randomly. In our next lecture, or in the pathfinding lecture on Friday, we're going to do some more advanced pathfinding stuff. But for now, it's just going to be like randomly wandering around. So let's implement that quickly. So the high level idea here is going to be try to explore in just the same direction as long as you can. And then if you run into a wall, then you can turn and try to go in a different direction. But for the most part, it's just going to be wandering around. So let's implement that. So let's see. First, we want to check if our robot is even allowed to move, because robots can only move once per turn. And there's other things that might like increase the movement cooldown and prevent a robot from moving. So first we want to check if our robot is able to move with rc.isMovementReady. And then once we've done that, we want to just sort of randomly wander around. So first thing we're going to try to do is continue in the same direction that we've already been going. So in order to do that, I've made this variable direction here that keeps track of our current direction that the robot is moving in. So if that current direction is not null, like it's already initialized, and the robot can move in that direction, then we're just going to go ahead and move in that direction. Again, this is just to prioritize like continuing in the same direction if we can keep wandering in the same direction. Otherwise, if we were not able to move in that direction, then we're going to pick a new random direction to move in. So to do that, we'll say direction equals, so our direction class dot, this gives us all the possible directions. And then we'll index into that with a random number that will pick the direction that we're trying to go in. So all directions of, and then I already made a random object in robot player. So we can just say robot player.random.nextInt, and there are 8 possible directions. So there we go. this should make the robot just sort of wander around randomly. That looks good to me for now. We're going to add some more stuff later. Okay, so back to setup. And now all we have to do in setup is call this method that we've made in our pathfinding class to explore randomly. So we'll just say pathfind.explore and pass in our robot controller. Yeah, so that's pretty much it for like our very beginning of the game strategy. Does that all make sense? Does anyone have any questions? All right, cool. Okay. So after that, our strategy is going to be to try to place down the flag. If you maybe remember from the spec, we're not allowed to place flags less than 6 units from each other. So we're going to check if we're allowed to place the flag at the current location. And if so, we'll place it. And then after that, we'll try moving towards our place flags and building defenses around them. So first, let's work on this. All right. So to check if we're able to place a flag at a location, we can use the rc.sense, I believe it's sense, yes, sense legal starting flag placement and at our current location. So if it's a legal flag placement, then we want to check if the robot actually can drop the flag, like if it's carrying a flag, see.get location. And if it's a legal flag placement and the robot like has the flag and is able to drop it, then we'll say rc.drop flag at that location. Okay. So yeah, that's pretty much it for placing the flag. It's just going to end up in a totally random spot based on where the robot was wandering. So again, it's not very strategic, but it will at least move them from the spawn locations, which are usually not the best places to put your flag since they tend to be like close to the dam, and you would probably want to put it somewhere with better defense. Okay. So after we try to drop the flags, another thing we're going to try to do is search for nearby flags. And if we can find a nearby flag, move towards it, like sort of make a defensive cluster around it, and also try to build some traps. So we're going to use the same method that we used before to sense some nearby flags. So we'll say rc.sense nearby flags. Again, we'll do -1, and we'll only want to get flags from our own team. And then we're going to loop through those flags and make sure that all those flags are actually placed on the ground, since it's possible that the flags that we sensed here are actually flags that are being carried by a robot, and we only want to build defenses around ones that are on the ground. So in order to do that, I'm just going to write this code here really quick. It's not too interesting. We check if the flag is picked up. If it's not picked up, then we set flag equal to that, and we break out. So this code is just for finding at least one flag that is on the ground that we want to build defenses around. So again, not too complicated here. Then if we were able to find one of these, because if the target is not null, if we were able to find at least one flag on the ground, then we're going to move towards that flag, and we're also going to try to build defenses around it. So as of right now, we don't have a super easy way to move towards a specific location, but that's going to be like a utility type thing that will be very useful in general. I think there's going to be lots of cases where we would want to move towards a specific location. So we're going to implement a quick method to do that. So to do this, we have a very helpful method here that lets us get the direction from our current location to another location. So we're going to initialize the direction here and say, we're just trying to find the direction from where the robot is now to where the robot is trying to go, which is this block parameter. So we'll say direction equals rc.getLocation dot, then we can say direction to, and then pass in the other location. And this gives us like the nearest of the 8 directions to pointing from our current location to the location we're trying to get to. So we find that direction, and then we say, if we can move in that direction, then we move in that direction. Cool. Otherwise, there's a few things that could have possibly been in our robot's way. Like maybe it was another robot, maybe it was a wall, maybe it was the dam, but it could possibly be water. And in that case, instead of trying to like pathfind around it and find a new way, we're going to try to just fill the water and go across it. So we'll say else if RC dot can fill. So yeah, okay, this is a little bit of a mess, but we're just going to get what that location is. And to do that, we can do rc.getLocation. And then we have this dot add method that basically finds the location that's in a certain direction from the original location. So rc.getLocation.add, and then direction. And we check if we can fill that location, then we want to fill that location. So we'll say rc.fill, rc.getLocation.add, that direction. Otherwise, if we weren't able to just move on to the location and we also weren't able to fill the location, then we'll just move in a totally random direction, which again is not a good strategy. Don't do this. Your bot will just sort of like jiggle around randomly, but it's going to be good enough for today. And if you come to the pathfinding lecture on Friday, we will show you some more sensible things you could do. But for now, we'll just move randomly, and it's going to get a random direction, random direction equals direction dot all directions of, and then just get a random number. And then we'll just, if the robot can move in the random direction, then we will move in the random direction. Okay, now that we have this move towards method, another useful thing that we could possibly do is while we're exploring, instead of just wandering around randomly, it might be slightly more strategic if we at least make some effort to try to pick up bread or crumbs. So let's sense nearby crumbs, and if there are any, let's try to move towards them. So we'll say application crumb locations equals, we have a sense crumbs method, sense nearby crumbs. We want to do -1 to get as many of them as possible. And then we'll just say, very simple, we'll just say if we found at least one crumb, just if the length of that was greater than 0, then we'll move towards whatever the first one was. So we'll say direction equals rc.getLocation.direction2, and then first one. And then if we can move in that direction, then we'll move in that direction. So yeah, this is our updated exploring logic. The goal here is now it should wander around randomly. If it runs into something, it will pick a new random direction. If it sees crumbs, then it will go directly towards the crumbs. Oh, sorry, I meant to use my move towards method here, which would be a lot simpler than doing this all again. So let's actually just do that. Saves us 2 lines of code. Move towards RC, and then from locations of 0. Okay, so that should be good. Let's go back to our setup file. Now we have our move towards method that we were just working on, and it's ready to use for moving towards nearby flags. So let's do that. The first thing we're going to do is pathfind.move towards, and then location of our targets.getLocation. So try to move towards any placed flags. And then if we're within a certain range of a placed flag, we're going to start building some defenses around it. So in order to do that, we'll say if our location, if the distance from our location to the flag that we're moving towards, not just the distance, this is the squared distance. So I assume you guys have encountered this by now. It is a little bit confusing that we measure all of our distances squared instead of just the actual distance. But this is just so we can avoid using floats and just use ints instead. So I'm going to say if it's within 3 of the flag. So we'll say if the distance squared is less than 9. Let's see, why is it angry? Target.get location. Okay, if we're close to the flag, then we're going to try building our explosive trap. So if rc.can build, we'll pass in the explosive type, and we'll pass in our current location. If we're able to build a trap at our current location, then build a trap at our location. And otherwise, if we're not able to build a trap, we'll also like just try making some random water, which again is maybe not the most strategic, but we should end up with some explosive traps and some water surrounding our flag for defense. So I'm just going to pick a random location to put the water in. You can't dig on your own tile, so that's why I'm not checking the current location. We're just going to try to make water on like any of the neighboring tiles. So we'll say our current location dot add, and then again we're going to pick a random direction. Getting kind of tired of typing this, to be honest. All directions of random. Okay, so we get a location for our water, and we say if we can dig at that location, then dig at that location. Okay. Now, if there was no flag to move towards, then we'll do our default behavior, which is just going to be moving randomly. So pathfind.explore. And that should be pretty much it for our strategy for the setup phase. And now it is time to go test out our bot. So let's go to the client. And we can pick the bot that we want to run. This is lecture player. We'll just try running it on the small map first. So we pick the map, and then you can just hit run game. And let's hope this works. Okay, it looks like things have gone horribly wrong. So this will be your lesson in debugging. Let's see what happened. There was a null pointer exception in pathfind.explore. So line 35, let's go there. Yes. So I believe I forgot to move here. Yes, so that's one issue. That's not actually the issue though. Check if we can't move. The other issue is I actually haven't initialized the random object yet. I also kind of glossed over this, sorry about that. But this random object will just let us generate random numbers. And I have it stored just in our main robot player class for convenience. So at the beginning here, it's set to null. So we want to check if our random is null, and in that case, just instantiate it to a new random object, which we need to do in order for the random to work. So we'll just say random equals new random. Another mildly important detail here, if we were to just make our random object like with a seed, like if we were to type in our seed here, then all of our robots would end up doing the same thing. Like they would always make all the same random choices. And we do not want that. So a pretty good idea if you're using random is to make your seed be the ID of the robot. So we'll pass in our seed.getID as the seed for our random generator. Okay, I believe that should fix it. Let's try it again. If you leave the seed empty, I believe it will pick a random seed, but I think it might pick the same random seed every time. I'm actually not entirely sure. If you leave it empty, it might be fine. But just to be safe and like make sure that all your robots actually do different things, I think it's a good idea to put in rc.getID. Okay, let's try it again and hope that we have better luck this time. Yeah, this looks good. Okay, so once it's done, let's slow that down a bit more and see what it did. So go back to the beginning, slow things down. Maybe not that slow. Okay, so we can see our robots are just moving around randomly. When they can, they go in straight lines. Speed it up a little bit. Once we get to around 150, they should start trying to place the flags. Yep, so they place their flags, and then they all sort of cluster around them, build some landmines, and add some water. And yeah, this looks like a pretty decent beginner setup phase strategy. Again, like you might want to be smarter about where you place your flags as opposed to just this random strategy, because like they all ended up really close to the border here, which is not a great idea. But at least they built some defenses. So yeah, that's it for the setup phase. As we can see, like after around 200, our bot just kind of sits still and does nothing because we have this check here. We only run that for the setup phase. Otherwise, we run this for the main phase, and we haven't written that yet. So let's get on to our main phase strategy. And for that, I will turn it over to Livia.
Okay, so after the like setup phase, we want our bots to actually like do something in terms of like trying to get, the flags and winning the game. And so that's what the main phase is going to be about. The first thing we want to set up though is like just having the bots move first, because we see how they sort of just like sit still in the beginning. And so right here we can go to like this check where it's for essentially saying like if the bot doesn't currently have a flag, then they're going to sort of just move towards the closest enemy flag, which is like just like a very simple strategy. We want to capture the enemy flag. So if you're not holding a flag, you just want to like move towards that flag. And so for that, we can just sort of make an array of sort of just like the nearby flags. Sorry, I'm like messing this up.
Or here we want to do an array list.
Oh yeah,
because of
yeah. I'm looking
reasons.
weird reasons. Okay, of like map looking. And then we're just gonna collect information on the enemy flags in terms of like location of like what we can see of them. So we're gonna use the sense nearby flags. Also set that to -1 so we can see as many as we can get. And then specify that we're looking for enemy flags by using the get team and opponent. And then we're just gonna iterate through this in order to just add all the locations of the enemy's flag that we can see to the enemy flags. And then afterwards, we're just going to check that if that flag location isn't currently, if the flag location exists and isn't right here, we're just going to move towards it essentially. The thing is also there's like broadcast locations in this. So for flags that are a singular robot can't see itself, that it might be visible, but through the eyes of essentially like the other robots. And so where you can also use that to sort of just see what more of like the enemy flags beyond just like the robot. So like if our flag locations like array is empty, then it's going to check the broadcast flag locations so it can have like essentially just like a direction of like where to go. Okay. And then just the actual moving towards the enemy flag. And then we've already, I think I've already discussed how we sort of move towards things. So.
We need to call the find closest flag or find closest location thing.
Oh, I see. Yeah. Or we're gonna just look through all the enemy flag locations that we have access to and just get the closest one.
And we just already implemented that method at the bottom of the screen, but I figured it was too boring to bother going through.
Yeah,
It just, given a list of locations, finds the closest one.
that's over here. And you'll have access to that. Okay. And then, of course, like if there's absolutely no flag information, then we're just going to like explore randomly like we did before.
Or we also need to try to pick up.
Yeah. Oh, and then if the robot is holding a flag, right, because that's what the else statement. If the robot is holding an enemy flag, then it's also going to change its movement patterns to
Like here, we need to pick up. Yeah.
I see. If a robot is close to an enemy flag and the enemy flag is like within range, so if the robot can pick up the enemy flag, then it also has to do that. So we check that every time the robot is moving. And then afterwards, that if the robot is holding the flag, then we make sure that that robot tries to move towards like the spawn locations so that it can, like return the flags to like home base essentially. So in order to do that, we just get an array of all of our spawn locations, which we can do with get ally spawn locations. And then we just take the closest one. And then we have a method for that too.
And this is just an annoying Java thing because that method took in an array list and we had an array instead. We have to do arrays.asList. Yeah.
And then we just actually move towards that closest spawn location. Okay. And then, so that's sort of like the basics of like the movement. So it'll move towards the enemy flags. And then if it can't see any enemy flags in the like immediate vicinity of like the bot's like view of sight, then it'll move towards enemy flags that are broadcasted towards like the shared vision that the bots on one team has. And then if there's still no like flags that it can see, it'll move randomly. And then if the bot is currently holding a flag, it'll try and move towards the spawn locations.
Oh, that's because the capital G.
My bad.
Then, wait, I think all the other ones are because of missing imports. So at the top, just put
Oh, I see.
import java.util.star. This is the easiest. That should hopefully fix all of them. Oh,
I spelled it wrong. My bad. Okay.
hopefully that fixes all of them.
Yeah, okay, it's
Yeah.
fine now. All right, and then so the next thing that the bots have to do is, so as you know, these bots, they can also like attack and they can like heal. They're like they can attack enemy bots and heal friendly bots. So we also want to add in a little like simple like movement behavior for that. So sort of just if you can attack and like if you can heal, do so. In particular with attacking, we're going to prioritize attacking bots that are currently holding ally flags naturally so that, to prevent them from being able to reach their spawn locations. And so for that, we're going to just get an array of all nearby enemies. -1 once again, so we can see all of the nearby enemies. And then we're going to get the opponent's team once more. And then after that, we're going to, like we said, we're going to prioritize bots that are holding our flags. So if the robot like in nearby enemy has flag, or like for each robot in the nearby like enemies array, if it has a flag, we're going to try and attack it first. Once again, we're using our helper methods from Pathline. And then we're going to check if the robot can attack, then it will. And then that's essentially that in terms of like attacking robots that are like, holding the flag. And then if the robot like isn't holding the enemy flag, it'll just attack it anyways if it can. So another iteration through all of the enemy robots that we have, all of the nearby enemy robots that we have. And then we're just going to say if we can attack. Attack that robot. Yeah. And so another thing that the robots can of course do is heal their like allied robots. So this is also very simple. We're just going to check for all of like the robots that are nearby that are like on the same team as our like as a current robot, and they're going to check if they can heal them, and then if they can, they will. Again. If can heal. And we're going to and that's sort of like the basics of just like very like simple like moving towards enemy robots and then attacking them, and then also healing our allied robots when they're if it's possible to. Another thing that we haven't done yet considered are like the global upgrades. So every 750 rounds, we get points that we can use to buy global upgrade. So very simply, just we're just going to check if we can buy the global upgrades. We're going to start prioritize the action upgrade and then the capturing upgrade. And then
We wanted to advertise the capturing global upgrade here because nobody is using it, which is making me sad, but we might add a buff to it in the near future.
okay, there we go. All right,
Looks good.
yeah,
Or there's a missing S right there.
yeah. So I think this should be in terms of just like this covers most of the bases of like what like a bot can do. They can move, they can attack, they can heal, and of course, like don't forget to buy the global upgrades because they do add like a buff to like your entire team, and so we can just sort of like test out how the bots will now act in.
Remember to save it.
Oh yeah, I did. Let
Sure.
me just command S. Oh,
Or yeah, just do Command S. There it goes.
okay. Use the Mac.
Yeah, my computer's weird. Yeah, it should be good.
Okay, so we're gonna just run the same game again. And we're gonna see how the bots act after round 200. So as you can see, we can already see that like more is going on beyond just the setup phase, flags are captured and such. So we didn't even make it to 750 turns, so there were no global upgrades, but if we go all the way back.
Or it's the one after that. Like that one's like the slow down one. That one just goes back a turn.
Oh, okay.
Or yeah. Or just like click the beginning here. It's kind of annoying.
There we go. So let's go to round 200 because that's where we left off last time. We're just going to look a little bit at just the robots and how they move. So, oh, is it going in reverse?
No. I don't think so.
It was.
Oh, really?
Yeah. My bad. But yes. Okay. So after round 200, we see how like the robots, they start moving towards each other, towards opponent flags. They're attacking and killing each other.
Go to the game tab.
Yeah. We can see sort of
I guess
specialties exist.
they're not really doing enough to specialize in anything, but they're trying their best.
Yeah.
We've got level 1 healer, yay.
Nice.
Yeah. Yeah, especially on this map, like they try to get back to the spawn zone, there's these things and they just end up bouncing around forever. It
Yeah.
looks a bit better on some of the other maps, but yeah, their random pathfinding is pretty awful, which we will improve on later.
Yeah. And in terms of specialty, of course, like when you're making your own bots, you can try to have them like some bots prioritize some actions more than others so they can actually end up specializing in a thing as opposed to just like nothing really. And so
We will probably at least get some healer specializations, it looks like, by the end. Oh,
no.
no, they tried.
No.
They tried.
But yeah, so they moved. The robots did indeed do a thing, and one of the teams captured all the flags, but it's the same bot fighting against itself. So that's sort of all of it, right?
Yeah, I think that's pretty much it. Do you guys have any questions about our basic strategy? Cool. All right. I think that's about it for today. We're going to post this bot online. Probably we'll just add it to the Battlecode 24